In this video, we're going to solve equations that contain inverse trig functions. Okay, so let's start here to solve. We want to solve for x. We can first divide both sides by 4. So we have arc sine of x is minus pi divided by 4. Now, as we've talked about, when you see an inverse trig function and it's given to you, you don't introduce it into the equation in order to solve the equation, then we're thinking about this as the true arc sine function in the sense that its range is minus pi over 2 to pi over 2. Okay, so we want to consider that as we solve these equations, but actually in this case, it works out to where it wouldn't have mattered if we didn't actually have to even think about that because, okay, so we want to take the sine of both sides of this equation. Sine of arc sine of x is just x, and then we've got sine of minus pi over 4, and it works out to where this is actually the sine of an angle is a single number no matter what. You know, the trig functions are functions in general throughout their entire domain. So we didn't actually have to even think about the fact that this is actually truly the arc sine function and has that range. Its range is only a certain range from minus pi over 2 to pi over 2. But in upcoming equations, it's going to be important for us to think about that to make sure we understand that what's given as an arc, as an inverse trig function, we're thinking about it as a true inverse trig function. Okay, so, all right, pi over 4 is 45 degrees. So what is, if we have minus 45 degrees, we're in the fourth quadrant with reference angle 45 degrees. So let's see, we've got, with a 45, 45, 90 triangle, you've got 1 minus 1 root 2. So sine of minus pi over 4 is opposite of our hypotenuse, so minus 1 over root 2. Okay, so we can rationalize this, and we've got minus root 2 over 2. And that's it. That is the only, that there's not multiple x's that satisfy this equation like we saw with trig equations. This is it. This is the only answer to this. There's only one angle that when you take its sine value, you get a number, and then when you multiply that number by minus 4, you get pi. There's only one. Okay, here let's start off by dividing both sides by 4/3, and so we're going to have pi over 1 times 3 over 4. So you've got 3 pi over 4. So now let's take the cosine of both sides of this. Okay, so x is 4 cosine of 3 pi over 4. So, okay, now what is 3 pi over 4 in degrees? Pi radians for every 180 degrees. So that's 135 degrees. So cosine of 135 degrees, that's reference angle 45 in the second quadrant. So minus 1, 1, root 2. So minus 1 over root 2. 4 times minus 1 over root 2. So let's see, minus 4 root 2 over 2. So x is equal to minus 2 root 2. All right, now here we could just, let's divide both sides by 2. Okay, now take the cosine of both sides, and so we're left with okay, now again, there's only one value here. This is the cosine function. We don't have to think about the idea of, since we introduced cosine, that there's all these potential values. We don't, that doesn't matter. This cosine of pi we know is -1. So we've got, let's see, x minus pi divided by 3 is -1. So x minus pi is equal to -1. So x is equal to pi minus 1. Okay, now here, this is a little more complicated because we can't just take like the sine or the tangent of both sides. We're going to be stuck with an inverse trig function. So we want to think about, though, that anytime we see an inverse trig function of an actual value, not a variable, remember, we're presented with this. So we don't have to think about, all the potential, there's an infinite number of angles. When you take their tangent, you get 3/4. No, there's going to be, we think about the inverse tangent function. Inverse tangent of 3/4, according to the inverse tangent function, is going to be, so tangent, the inverse tangent goes from -pi/2 to pi/2. There's going to be one angle here, just one. So we could, that's one way we could do this. We could just go ahead and find this angle. But another way to do it is, and we worked problems like this actually in section 1, we could actually go ahead and say that we've got, so u is equal to arc tangent. We don't even have to evaluate this. But it would be good practice if you had a more complicated equation. Anytime you see like an inverse trig function given to you with a non-variable, go ahead and evaluate it. But just to show you, we don't technically in this case, we don't have to evaluate it. In other cases, you would have to. It'd be very useful to evaluate it. So if we say u is equal to arc tangent 3/4, this is an angle, right? Because all the inverse trig functions, what comes out of an inverse trig function is an angle. You're asking what angle, when you take the trig function of that angle, do you get the argument? So, okay, we've got arc sine of x is equal to u. Now we can take the sine of both sides of this here. And so sine of arc sine of x is just x is equal to sine of u. So we don't actually have to find arc tangent of, we don't have to find u, we just have to find sine of u. So how can we analyze the angle u? Well, okay, we've got some information right here. We've got arc tangent of 3/4, but now, normally we would think, that so tangent is, it's positive 3/4, tangent's positive in quadrants 1 and quadrants 3, but no, remember, we're given this. So we're only considering the range of arc tangent, which is quadrants 1 and 4, so it's positive, so we're in quadrant 1. So, okay, opposite over adjacent is going to be some angle that's less than 45 degrees. So okay, it's telling us that the tangent of u is 3/4. So that means that this has to be the case. Opposite over adjacent. The tangent of u is 3/4. But to get x, we need the sine of u. So opposite over hypotenuse, we need the hypotenuse. Well, 4 squared is 16. 3 squared is 9. 9 plus 16 is 25. Square root of 25 is 5. Okay, and there we go. So sine of u is 3/5. Okay, same type of problem here, but let's actually go ahead and we see this inverse sine of 3/5. Well, this is just a single number, right? The inverse sine function. So let's just turn this into a number. So, all right. So what angle? It's going to be positive 3/5. What angle in the first quadrant, when you take its sine, do you get 3/5? Well, that doesn't correspond to a special angle. So, okay. 36.87. So, okay. And this is in degrees. So now all we need to do is just take cosine of both sides. Okay. 0.8. Okay, same idea here. We've got this inverse tangent of 1, but we're not having to think about all of the potential, the big picture here. This is the inverse tangent function. There's one value here. So let's go ahead and convert that to a number. So we've got a all right, 1 root 2. Tangent of 45 is 1. So, but we're in radians here. We can see, so 45 degrees is pi over 4. So this is going to be pi over 4. Okay, now we add pi over 4 to both sides, and we get, okay, now what is sine of 0? That's just 0. Okay, so here we see we've got an inverse trig. We're given an inverse trig function of a value, not just a variable. Let's go ahead and evaluate this. So, okay, what angle, when you take its sine, do you get root 3 divided by 2? We can think about the 30, 60, 90 triangle. Okay, so a sine of 60 is root 3 divided by 2. And so for arc sine, we're thinking about the first quadrant as far as a positive number. So what is 60 degrees in radians? That's pi over 3. So, okay. All right, now let's subtract 2 pi over 3 from both sides. So we've got 3 pi over 3 minus 2 pi over 3. So okay. Now we can take the cosine of both sides. Okay, so now cosine of 60 is 1/2. So you see the advantage of when you see an inverse trig function, you're given an inverse trig function of an actual value, you can go ahead and evaluate it, turn it into a number. Okay, now this is a little bit more complicated because now we've got these two different inverse trig functions, arcsine or cosine, but then neither one of them have just a non-variable argument that we can just evaluate. So, okay, what we're going to need to do is we can subtract either one of these from both sides. Let's subtract arc cosine from both sides. Okay, now let's take the sine of both sides here. So, okay, this is going to become 2x. And then we've got okay, now we can divide, let's see. Okay, now where do we go from here? Okay, this is another situation where it's useful to remember that, like, an arc cosine of x, that's an angle. Any arc, whatever, these are angles. The inverse trig function of something is an angle. So if we say that u is equal to arc cosine of x, okay, then now we have a better view of this, in the sense that this is an angle. So we can, what we want to do next is break this up using the difference formula for sine, difference trig identity for sine. So sine of alpha minus beta is equal to sine of alpha cosine beta minus cosine alpha sine beta. So this is 1/2 sine pi over 6 cosine u minus cosine pi over 6 sine u. Okay, so the advantage of this is that now we just need to analyze the angle u, similar to how we've done in previous problems, in that if we can analyze the angle u, we can, with a triangle, we can potentially get the cosine, get the sine, then we can get x, right? So, okay, let's draw the triangle then. However, there's an issue here. The issue is that we don't know that we don't know the quadrant of u. So we have to think about, so okay, u is arc cosine x. That's fine, but that's two potential quadrants. Even though we're considering the fact that this is a true inverse trig function and the range is limited, there's still two potential quadrants here. This would be, 1 or 2. So we don't know if it's 1 or 2. So what we need to do is, so okay, we know that, so arc cosine is, the output is somewhere between pi and 0, or 0 and pi, right? But we also have some more information here. We have some information about arc sine of 2x, okay? So, but the output of arc sine of 2x is going to be what? It doesn't matter that we have a 2 in the argument. What's the output of this going, the potential outputs? For arc sine, no matter what the argument is, it's going to be between minus pi over 2 and pi over 2. So we can say this. We could do this. Pi over 6 minus arc cosine of x, we know needs to be, it's going to be less than or equal to pi over 2 and greater than or equal to minus pi over 2. That's a fact. Doesn't matter that if this could be arc sine of anything, it doesn't matter. So now what we can do is we can subtract pi over 6 from all sides of this. So, okay, let's see. Multiply minus pi over 2 times 3 over 3. So minus 3 pi over 6 minus pi over 6 is minus 4 pi over 6. So, okay, minus 2 pi over 3. And then you've got, let's see, pi over 2 minus pi over 6. So that's 3 pi over 6 minus pi over 6 is 2 pi over 6. That's pi over 3. So pi over 3. But now we want to multiply this entire inequality by minus 1 so we can get arc cosine by itself. And then what that means is we're going to need to flip the inequalities. So let's just go ahead and flip them first. And then so we got minus pi over 3 and then 2 pi over 3. So now we can bring this over here and let's see, it's minus pi over 3 is less than or equal to inverse cosine of x, and that's less than or equal to 2 pi over 3. So all this is telling us is that in order to honor the range of arc sine of 2x, this arc cosine of x needs to be within something between minus pi over 3 and 2 pi over 3. Okay, but we know that arc cosine of x can't be negative. So we can just like combine these two. Like we know this will never be negative anyway. So we can, like, the idea is this specific arc cosine of x in the context of this problem, we know is going to be, can only be something between 0 and 2 pi over 3. Okay, so now ideally, what we would typically see with an example like this is that at this step, we would have constrained arc cosine x, the outputs of arc cosine x based on the problem, to a certain quadrant, because this is an angle, right? It's u. U is an angle. We would have constrained it to a certain quadrant. Then we could go ahead and start and draw the angle and its triangle and figure out what cosine of u is, what sine of u is, and get x. However, there's an issue here in that we see that this goes from 0 to 2 pi over 3. This corresponds to 120 degrees. So it's not quite constrained to the first quadrant. It's an improvement from 0 to 180 degrees, but still. So what are we going to do here? Well, we can think about that. This is a special case where there's a symmetry here. And that, so, okay. So if this is 120 degrees, so we know that u is somewhere from in this range, right? If u is greater than 90, that means cosine of u is negative, x is negative. If u is less than 90, then cosine of u is positive, x is positive. But if you think about it, it actually is not going to matter which quadrant we pick u to be in this case, because of the symmetry here. So let's say let's say we had it at 120. There's one possibility. And let's say we had it here. There's another possibility. So there's one option for u, and there's one option for u, and there's another option for u. Okay, so all right. If we think about, so okay, cosine of u is x, right? Cosine of u is x. So that means adjacent over hypotenuse is x divided by 1. So okay, in quadrant 1 we've got what? X, and we've got 1. Well, in quadrant 2, we just put x again. Now, you might be saying, well, wait a minute, won't that create an issue? Like, well, how can we just do this? The reason why this is going to work is because there would be an issue that would come up if it was the case that we had the sign of this coordinate was changing. Then it would be a problem. But we've lucked out that it's not. So what I mean is, so okay, this is going to be 1 minus x squared, okay? What if it was the case that when we came into this quadrant, that this was a negative coordinate? Then we'd have to have like two separate scenarios if x is positive or negative, but this is going to be the exact same anyway. This coordinate is going to be just square root of 1 minus x squared, no matter what. Because, right, x squared it doesn't matter if it's positive or negative. And so that's the idea. Cosine of u could be positive or negative, depending on where u is, but okay, that's just x. X can be positive or negative. It's just a variable, right? Well, sine of u, that would create an issue. If sine of u could change, well, then we'd have to, that would create complications. But sine of u over from 0 to 100 for this entire range of what u can be, sine is the same anyway. So that's why it works out. Okay, so we can see that cosine of u is going to be x. Sine of u is going to be Okay, so now what about sine of pi over 6 and cosine of pi over 6? Let's see. Pi over 6 times pi radians. This is 30. So, okay. Let's see. We've got 1 root 3, 2. So, okay, sine of 30 is 1/2. Cosine of 30 is root 3 over 2. Okay, so we've got, let's see, x is equal to 1/2 times 1/2 is 1/4. So x over 4. Then we've got minus 1/2 times root 3 over 2 is root 3 over 4. Okay. So now we just need to solve this radical equation here. So, okay, we've got root 3 over 4. Okay, now 1/4 x minus x is minus 3/4 x. Okay, now let's square both sides. So we've got 3 over 16 times 1 minus x squared. Okay, now let's divide both sides by 3/16. So we've got 9x squared over 16 times 16 over 3. Okay, so 1 minus x squared is equal to 3x squared. So 4x squared is equal to 1. X squared is equal to 1/4. X is equal to plus or minus 1/4. Now with radical equations, we need to make sure that there's not extraneous solutions. So there shouldn't be, or no, this would be plus or minus 1/2. Okay, so let's see. Let's try positive 1/2. X is positive 1/2 divided by 1/4 is 1/8. Okay, 1 minus 1/2 squared, that's 1 minus 1/4, which is 3/4. So root 3 over 4 times root 3 over 2. 3 over 8. One half is not equal to minus 1/4, so positive 1/2 is not a solution. Now let's see. If with negative 1/2, we'd still get this, but then this would be negative and this would be negative. So let's see. 3 over 8 minus 4 over 8. Okay, there we go. So there's only one solution to this radical equation. It's minus 1/2. And so there you go. X is minus 1/2 is the solution. Okay, similar type of problem. Let's subtract either one of these inverse trig functions from both sides. So we can do okay, now let's take tangent of both sides of this equation. So we've got okay, So now we can think about if u is equal to inverse cosine of x, that's an angle. So we've got x is equal to tangent of pi over 2 minus u. Now we can take the sum of difference formula for tangent. Tangent of alpha minus beta is tangent of alpha minus tangent of beta over 1 plus tangent alpha tangent beta. So we've got tangent of alpha minus tangent of beta over 1 minus or 1 plus tangent of alpha tangent of beta. Okay, now, but there's an issue here in that tangent of pi over 2, we know that's dividing by 0, going to infinity. But we can still think about evaluating this if we say that we can do this. We can say the limit, as in, let's say maybe a, as a goes to infinity, of a minus tangent of u over 1 plus a times tangent of u. Okay, so we learned these limits in calculus. So what we would want to do next is do this. Multiply this by 1 over a divided by 1 over a. So we get 1 minus tangent of u over a, and then 1 over a plus tangent of u. Now, tangent of u is going to be an actual number, a finite number. So as a goes to infinity, these terms go to 0. And you're left with 1 over tangent of u. So we can write this as 1 over tangent of u, which is cotangent of u. So x is equal to cotangent of u. Cool. But now we need to get some information about u. What quadrant is u in? Once we can get a sense for the quadrant of u, some information about u, then we can analyze what cotangent of u would be. So, okay, here we know that from this position, u is going to be something between 0 and pi. Okay, now are there any other constraints? Well, we've got this here. We know that, so arctangent it has range from minus pi over 2 to pi over 2, so we can say this. Pi over 2 minus inverse cosine of x is going to be less than or equal to pi over 2. Okay, so now if we subtract pi over 2 from both sides, so minus pi over 2 is minus pi. Then we've got, okay, pi over 2 minus pi over 2 is 0. Okay, now if we multiply this by -1, now we flip the inequality. Okay, so now just reorienting this, we've got cosine x is less than. Okay, so this actually doesn't help us constrain anything because it was because this pi over 2. Okay, now maybe there's a symmetry here that we can work with. So, okay, we've got, let's see, we know we're in the first or second quadrant, so but we have no idea where. It could be anywhere from 180 to 0 to 180. So let's put a angle here. Let's put an angle here. Okay, these are both potential u values. Right, this could be u or this could be u. Okay, so, all right, cosine of u is equal to x. So, all right, that's fine because x can be negative, right? X is just a variable, so that's okay. But now we need there to be a consistency here. In order to generalize this, we need, and the consistency is going to come with the cotangent. So cotangent is going to be adjacent over opposite. So the adjacent's not a problem, the x, but the opposite needs to not change, and we're okay there. It actually works out here. It actually will work out for any scenario when it comes to because we can make x negative. If we were going between the first and the fourth quadrant, there'd be an issue. So, okay, so this is and there we go. So cotangent is adjacent over opposite. So we've got x is equal to adjacent over opposite. So now we just need to solve this equation here for x. Okay, divide both sides by x and you get multiply by cross multiply. Now square both sides. 1 minus. Subtract 1 from both sides. Multiply both sides by minus 1. Take the square root of both sides. We don't need the square root property, so x is equal to 0. Now we need to check our solutions with radical equations. So yeah, 0, and then you have 0 over 1. So okay, that's the solution.